We are going to look at plotting parameterized functions onto our computer screen. So first of all, what is a parameterized function? Well, the best way to look at this is by an example. So we're going to draw the circle with radius 25 using a parameter. So you can see the little blue dot here, and what we can do is we can adjust it at 30-degree cycles. So that's 30, 60, 90, 120, 150, 180, and you can see here it works its way round in a circle. Now we've not actually plotted the points here, we're just generating the individual points so that you can see what's happening. So the parameterized equation is here. We're going to have the parameter, so the parameter is a value t. Usually whenever you're dealing with parameterized functions, you take the parameter as the letter t. So it's going to be greater than or equal to 0 and less than 2 pi. Now I've not added it in here, but we're only going to go round in 30-degree chunks. And we're going to plot off the point x and y. So you can see the brackets here. So in effect this is just an x and y point. So the x point is going to be the cos of the angle t, and the y point is going to be the sine of the angle t. So the cosine of the angle is going to be the x coordinate, and the sine of the angle is going to be the y coordinate. Now this here is a parameterized equation. What we want to do is generate a circle with radius 25. So what we need to do is multiply the entire thing by 25. So it means that the x coordinate is 25 cosine t and the y coordinate is 25 sine t. And as this value of t works its way from 0 to 2 pi, we're going to work our way around a circle. Now there's lots of interesting and fun things you can do with parameterized equations. For example, we could draw spirals, and there are lots of other examples that we could work through. But we just want to work through this one because it's quite simple to get a handle on it. So let's see the program that we're going to use in order to draw this parameterized circle on our screen. I have created this code in order to generate a parameterized circle on our computer screen. Now I'm not going to take this and save it as a subroutine in the ROM. It's just a bespoke piece of coding just to show you how we could potentially generate parametric functions. So I'll talk it through just broadly, and then we will see it actually working. So the first thing we want to do is we want to work out the cosine of the input t. Okay, so this little section here works out the cosine, and we've seen this before. All we do is we put the value in here, in this case into register R3. We jump to the subroutine cosine shift, so it will generate the cosine using the sine function which shifts the value, and we pop the result into R0. So we're going to have the output here is cos of the angle t, and then we have to multiply it by the value 25. So I've put 25 in R1, and then I've pushed the value R0 and R1 onto the stack. So that's the cos t and the 25 onto the stack, and then I've called the subroutine float fp underscore multiply. So that's a fixed point multiply subroutine, and then we return the value so we can pop it into register R0. So register R0 is going to be 25 cos t. So this is going to be our x coordinate. Now we want to do the same for the sine function. So we push the value R3, and then we jump to the subroutine for the sine, and this returns the sine function. And then we do the push of R1 and R2, so we're pushing the sine of t and also the value 25 into the multiply subroutine, it multiplies them together and it returns the 25 sine t. So that's us got our y coordinate. Now there's one other complication here which meant I had to generate another little subroutine. So we'll talk through that now. So if I had the point 25 cos t and 25 sine t, it's going to be in a fixed point number system. But if I want to actually plot that onto our little screen, the values in the plot, well, they're going to range from plus 128 to minus 128 in the x direction, and plus 128 minus 128 in the y direction, because we've only got 255 by 255, and I've generated the plot so that it plots from the centre, which would be 128 by 128, so it plots from that point. But whenever it plots, it doesn't know what the fixed point numbers are. That is, we can't take in a number, for example 27.3, and then try to plot it, because it would know how to plot the point 27, it just goes to the 27, but the point 3 is of no use to us. So what I've done is I've taken the fixed point numbers and I've ran them through a little decimal to integer conversion with some rounding. So for example, if we get the value 25.4, it will return, so this is the fixed point value 25.4, it will return just the integer value, which is 25. So it rounds it down. But if it's 25.5 or above, so for example if it was 26, it will return the value 27. And that does it here in this little subroutine called decimal to integer, dec underscore integer. So that's just a rounding and a conversion, which will allow us to plot the values. So once we've done these conversions, we're going to have the register R1 will contain the y coordinate, and register R0 will contain the x coordinate. And then we can push them into our little plot subroutine. So the plot expects it to have the x and then the y and then the colour. So we push the value R0, which is the x, and then the y and then the colour onto the stack, and we jump to the subroutine for the plot. And it goes through, and the subroutine for the plot doesn't return anything, it just plots a value onto the screen. Now once we've finished plotting it onto the screen, we're finished the first one. And then what we can do is we have a setup at the top here, we have a counter. So in this instance, I'm going to split the circle into 12 segments of 30 degrees. So I'm going to set up the index register with a value of 12. And I'm going to set up the initial value of so I'm going to set up the value of the increment, which is 30 degrees, but of course I have to write the 30 degrees in radians. So in radians, 30 degrees is going to be 0.52359877. Okay, so that's the jump. So if I wanted to change this, I would have to change these values. So if I wanted more points along the circle, I would have to change this count value in the index register. And if I wanted to space them out differently, so different angles, then I would have to change this value here for the angle, and I would have to change it in terms of the radians. So we don't have a subroutine for this, we can just go in and change it at these points, and we can just run the code. But there's nothing to stop us generating subroutines for these parametric equations, but it's just another route that potentially we could go down. We're in a happy position now where the only thing that's really limiting us is our imaginations. So whenever we get down to the bottom here, it's going to decrement the index register, it's going to check and see whether it's got a value of 0 in it. If it has got a value of 0, it means it's gone round the full circle and did all 12 points, and it will just end the program. Now if it hasn't, then what we're going to do is add the value of 30 degrees on so that the next one that comes in is going to be 30 degrees. So the first one that comes in is 0, the next one will be 30, it'll run through the code, and then it'll be 60, and then it'll be 90. And it'll continue through this until the index register is counted down to 0. At that point, it's going to jump to the end of the program, and that will be us finished. So let's have a quick look at the how we work through and turn the decimal values into the integer values. So we have this little piece of code here which I have saved as a subroutine in the ROM because it might come in handy later on whenever we're wanting to plot stuff onto the screen. So what we're going to do is take in the fixed point number, and the first thing we want to do is check and see whether the decimal part is greater than or equal to 0.5. So we can do this here, so we can AND the value R0, the register R0 with the value 0080. So 0080 is 0.5. Now if turns out that the value is greater than 0.5, then we jump to the round up. So we jump to this point here, and at that point there, because we've got a value greater than 0.5, we have to add 1 on to the integer value. So this adds 1 on to the integer value, and then we continue with the rest of the code. Now, if the value was not greater than, was less than 0.5, then we don't need to do this line here. We simply go down because we're going to round down. So we head down to the next line. Now, in order to do the conversion, remember we're converting from the fixed point just to an integer value. So if we shift the entire value 8 to the right, then we're going to we're going to get rid of the 8 least significant bits which contain the fractional part, and we'll be left with only the 8 bits for the integer part. And that's it finished. And then we can push the value integer onto the stack, and then from the calling function, so I've got another one here for the calling function. So from the calling function, we can then just save that value in the integer underscore x. So that's how the code works. Let's go ahead and I will show you the finished article. Now, it would take about 40 minutes or so for it to run through to generate these points. So it takes about 3 or 4 minutes to generate each point. So there's no point in me showing it actually running. I'll just show you the finished result. I have ran the simulation and this is the final result. You can see that we have generated a circle. We start off at 0 degrees, then 30, 60, 90, 120, 150 and 180, and so on all the way around the circle. So we are now able to plot off parameterized functions on our screen. And we've got lots of different ways that we can use this, and we're only really limited by our imaginations. So thank you for listening. I'll get you on the next video. Goodbye.